See this language, it says that we have any number of A's followed by any number of B's. What should be the deterministic finite automata for this particular language? See, A star B star means any number of A's followed by any number of B's. We can have a null string, so make initial state as the final state. Any number of A's are accepted. Then on reading B, move to the next state, Q1, make it also as an accepting state. Any number of B's are accepted. Is this a deterministic finite automata? No, not yet, because we have to show what will happen if Q1 sees an A. If Q1 sees an A, it will go to one more state, Q2, and make this Q2 as the trap state. Because the language is always having all A's followed by all B's, A will never be encountered after a B. So therefore, we will have, whenever Q1 sees an A, we should take a trap state Q2 and it will be directed towards Q2, and once it is on Q2, it is a rejected string. So take another example now. This example is for a language A that is followed by BB any number of times. So we'll make a deterministic finite automata for this. Q naught on reading A goes on Q1. Q1 on reading B will go on another state, say Q2. Q2 on reading B will go on another state, that is Q1. So we have A, B, B any number of times. But we need to complete the diagram. Make Q1 as the final state because we have single A followed by B, B any number of times. And we have, see, if we have seen the machine sees only one A, it will go to Q1. Q1 on reading B will go on Q2. Q2 on reading B will come back to Q1. So this will make the loop A followed by B, 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 B any number of times, and it is stopping on Q1. So Q1 is an accepting state. But let me complete the diagram. What will happen if Q0 sees a B? If Q0 sees a B, push it towards another state, say Q3. Make Q3 as the trap state because Q0 on reading B, if the string starting with a B, we should not accept it. The machine is not going to accept it because the language says that we have exactly one A, starting symbol is an A, and it is followed by B, B, the double B any number of times. What will happen if Q1 sees an A? What will happen if Q1 sees an A? It should go to the trap state again. What will happen if Q2 sees an A? It should also go to a trap state because by the given language it says there is exactly one A that is at the start of the string, and then after that we have double B any number of times. So this is the final diagram for the given language. See another example. String should not have AB as a substring. We have seen such type of example earlier also. So Q0 on reading A will move to another state, Q1. Q1 on reading B, take it to another state, Q2. Make Q2 as the trap state because once the machine sees A followed by a B, it should reject every such string. But remember that we have to make Q0 as an accepting state because null doesn't have AB. So null is accepted. Make initial state as the final state. Single A is also accepted to make Q1 as an accepting state. Now complete the diagram by showing what will happen if Q1 sees an A and Q0 sees a B. We will just make this. If Q0 sees a B, keep it here only. Any number of B will be accepted. Any number of B followed by a single A is accepted. And again, any number of A followed by single A should be accepted. But once the machine stops on A, that is the last symbol is A and the next symbol is B, A followed by B, once the machine sees this, it should be rejected because then A, B becomes a part of a string which is not required for this language. So therefore we have completed this diagram. We can see that the deterministic finite automata for string shouldn't have AB as a substring is of this form. Hopefully clear to all of you. If not clear, please do let me your doubts. Write your doubts in the comment. Now if I say strings should end with AB, what should be the diagram? It should end with an AB. Q0 on reading A is going on Q1. Q1 on reading B is going on Q2. Make Q2 as an accepting state, thinking that this is the end of the string. Now Q2 on reading A should go back to Q1 as it is ending with A followed by B. And if Q1 sees an A, it should stay here only as an A followed by any number of A followed by a B, string is ending with an AB only. And what will happen if we have seen B on Q2? If string sees a B on Q2, it will go back to Q0 and restart everything again. And next again for Q0 on reading B, Q0 on reading B stays here only. So the diagram is completed. If Q0 sees a B, it stays on Q0. Q0 on reading A will move to the next state Q1. Q1 on reading A will stay there only on Q1 as the requirement for the language is that string should end with an A followed by a B, AB. So Q1, any number of A, so the machine stays on Q1. Reading a B, it should move to the next state, that is the accepting state. And suppose we have string of this kind A, B, A. A, B, A is not having AB as the last two symbols. So see where it stops. Q0 on reading A goes on Q1. Q1 on reading B goes on Q2. And then again Q2 on reading A is on Q1. So it will take one more symbol, that is suppose there is one more B after this A. If this B is there, it will go back to Q2. And since Q2 is an accepting state, this string AB is accepted by the machine. Let me take another example. Strings having even number of A's and even number of B's. We do not have any fixed pattern for this, so we will just make the states as 4 different states. Even number of A's, even number of B's. I'll call this state as even. And then even number of the second one is even number of A's, odd number of B's. I'll call this state as even odd. The third situation where odd number of A's and even number of B's. We'll call this state as odd even. And one more state is there. Odd number of A's, odd number of B's. We'll call this state as odd. So we'll make deterministic finite automata taking these four different states. Even, odd, even, and odd. The question says that strings have even number of A's and even number of B's. That is this situation, this state, even. So we'll make even as the final state. This is the final state. Now when we have zero number of A's and zero number of B's, these are like even. Zero is an even number, so I'll put this as the initial state. Okay, when number of A's and number of B's are even here, on reading A, where should it go? If number of A's are even and I read this state read 1A, then A becomes odd and number of B remains even. Similarly, on this state, if I put this as this state even on reading B, it will become A remains unchanged, that is even, and B becomes even number. On adding one B on even, it becomes odd. Similarly, come to this state odd even. We have currently even number, odd number of A's. Odd number of A's, if it sees one, and even number of B's. If it sees one A, it will go back to this state. Odd number of A's, add one more A into it, it will become even, and even number of B's remains unchanged. Similarly, this state odd even, when it sees one B, it will go to the next state, this one, on reading B, because odd, the number of A's was odd and it is unchanged, it remains odd here in this state. In this state, it is odd. Similarly, even number of B's were there in this state, and it becomes, after reading one B, it becomes an odd number of B's. Now come to this even odd, this one. When the state is even odd means even number of A's and odd number of B's. On reading A, even number of A's, if it reads one more A, it will become odd. Even number of A's and odd number of B's. In this situation, if it sees a B, it will go back to this state and becomes even. Now odd state, when number of A's are odd, if I read one A, it will become even and it will go back to this state. Odd state, if it sees one B, it will become number of A's odd and number of B's even. So this is the deterministic finite automata for the given language. Hopefully clear to all of you. We have n number of examples. Please try on your own and let me know if you have any particular doubt. write your doubt in the comment box so that I can help you with the solution. Please let me know your comments in the comment box. Thank you so much.